Welcome to the Prosthetics and Orthotics Podcast with Brent Wright and Joris Peels.
Hello all, welcome to another episode of the Orthotics and Prosthetics Podcast. I am going to be hosting today, Brent Wright. Typically Joris is with me, Joris Peels is with me, but he is off today, but we're going to keep the show rolling. If you don't know about the podcast, what we're about is trying to find out what digital aspect of additive manufacturing, software, kind of all of the above has an application into the orthotic and prosthetic space. We're trying to figure out, is it here to stay? What parts are here to stay? What parts can be improved? Are there materials and such and techniques that are better, or things that we want to see improve? The idea is to try to get as many people in on the show just to share what they're doing in the corner of their world. And I'm super excited today to have Drew Meyer from MedEquip on, and he's going to share with us his journey today. And a little bit of background, or what I know of him. He is one of the stops that I made when we went across the country in RV in 2020 when COVID was crazy, and we really hit it off, and we've stayed in touch since then. But he's really been a pioneer in some of the idea of adoption of digital technologies for a one-man show. Essentially, that's what Drew is right now. And then he has a great vision of what works, what doesn't work, and where things need to improve. So, Drew, thanks for being on the show today.
Absolutely, Brent. Thanks for having me, man.
Yeah, Drew, I just wanted to start with, how did you get your start in O&P? And I know you have an engineering background, so I want to hear a little bit about how that ties in and your journey.
Absolutely. It's funny reflecting on the journey that I've taken so far, because my first job out of undergrad, so I graduated from Colorado School of Mines with mechanical engineering and a minor in bioengineering. And my first job out of undergrad was actually for a company that ended up being acquired by 3D Systems, and they used freeform. They were one of the early bleeding edge users of freeform and 3D printing with SLA machines. We had an SLA 350 machine, and it was slow as snot. It would take 18 hours to build one anatomical model, but it worked. And then over time, we acquired a SLA 250 or a 2500 and then a 3500, and then kept going up as the materials and the machines got better and better. But at the end of the day, that job for me it was a manufacturing job. I wasn't in a design role. I wasn't in any sort of role that interfaced with patients or any sort of patient care role. Definitely not healthcare, even though we were making medical devices. It was all anonymized patient data sets, and I didn't get that intrinsic reward of working with people and seeing the results in person. And so I went through a couple of engineering jobs, and at the end of the day, I was just like, oh man, I'm sick of sitting in front of a computer. I want to use my hands. I want to help people. And my wife is a nurse, and she worked in the hospital, and I'd hear her war stories of going to the hospital and helping people. And I actually got laid off from like a startup I was working at. They called an all hands meeting and just said, we ran out of cash, and the next week you basically start working for free. And I was like, okay, I'm going to go. That was the week before I got married, unfortunately. But fortunately, my wife was really gracious and gave me some time to do some soul searching, and really took the time to sit down and systematically look at different opportunities out there. So I looked at going back and getting my graduate degree in engineering. I looked at becoming a teacher. I looked at jumping out and becoming like a nurse or going to medical school. I shadowed some doctors and said, hey, what do I want to do? Went to different labs and ran across an assistive technologies lab that's based out of Denver, and talked to different people. And I was really just like honing in on, okay, I like this idea of assistive technology, but I don't want to do wheelchair technology. It doesn't seem like what I want to do. And I want to have some more education, but engineering grad school doesn't seem like the thing to do. And I was actually, since I was unemployed at the time, a lot of random people would ask me to do favors just in the middle of the week. Oh, Drew's not doing anything. Just see if he can give me a ride to the airport. And this friend had this random task and she asked for some help and she said, hey, I have a friend that needs to go to dialysis. Can you take him today? And I said, okay, sure. I'm not doing anything. So I take this random guy I don't know to dialysis. I'm in the elevator and this guy with a Hanger Clinic shirt gets on the elevator. And I remember I'm in job hunt mode, remember? And I'm like, it's all about networking and all that stuff. And I see this guy with a Hanger Clinic shirt. And I remember from my job hunting that biomechanics was one of those terms that I had been job hunting. And a Hanger Clinic ad had showed up. And so I said to the guy, hey, my name's Drew, looking for a job. Let's talk. And turns out he was the area BDM, business development guy. And he sent me over to the local area residency director and had me shadow him. And it's just one of those things where I'll never forget it. I went and shadowed this CPO for 4 hours at his clinic. And in the course of that time, he had an AK come in for a check socket fitting. A lady came in for an LSO. A baby came in for a cranial helmet. And I was just like, you get paid to do this? This is awesome. I remember this is my first interaction with really anybody that was an amputee. And this older guy comes in and he's in an AK check socket that's hooked up to all the components. And he walks in on it, pops the leg off and hands it to the CPO. And the guy goes into the back and pulls out a blowtorch and a grinder. And I'm like, you have a workshop with tools? This is amazing. And I was like, 4 hours of shadowing, I was like sold. I'm like, done. This is what I want to do. What does it take? So I went home and Googled, what is this orthotics and prosthetics field? And looked at, and I quickly realized, oh, shoot, I need to go back to grad school. I'd actually been accepted to an engineering grad school. And so I put in a deferral and was like, I don't think I'm going to do that right now. I deferred that and looked at going to grad school. And I'm in Colorado in the center of the U.S. and there are no O&P grad schools within any sort of close distance to me. The closest was either Chicago or Dallas. So I applied to O&P schools and ended up getting into the Baylor College of Medicine, which was like a brand new program at the time. And that's how I got into the field.
Wow, what a story. And talk about being almost divine providence, right? Right place, right time, helping you get rock and rolling. That is awesome. So
yeah, absolutely.
When did you finish at the Baylor College of Medicine?
So I was the second class to go through. I started in 2014 and it's a 2-year accelerated program. And so that got me through to 2016 was when I graduated.
Awesome.
Can we pause here one moment?
Yep.
You gotta be totally quiet and you cannot talk. You understand? All right, sorry about that. I got sick kiddos.
Oh, man, that's no good.
All right, carry on, sir.
All right. So let's see. All right, Drew. So you were at Baylor. You've made the transition. What was your first job out of Baylor? Let me start over. Okay.
Yeah.
Ooh, here we go. All right. So cool. So you finished Baylor. Where did you go next? What was the next thing? Is the job on the horizon, or what is next after you finish that program? Because that program is very unique in that you also complete some of your residency requirements during school. Is that correct?
Yeah, correct. It's actually, I think, very key in how the formation of kind of the mentality of where I'm at today, right? The program being a brand new program, I haven't gone through any other program, but all the instructors graduated from other programs. A lot of them went to Northwestern, for example. And they told me that they tried to set up the Baylor O&P program to be the program that they wish it had been when they went through. So we had almost fully digital curriculum. Everybody was issued iPads on day one. We took classes with the medical students. We had an accelerated program, so it was basically 8 to 5 all day, every day for a year with really very little breaks. And then, it's a 2.5-year program, not 2 years. So then then the 18-month clinical residency is incorporated and overseen by the school. So that's where they set it up to be more like a med school where the students, where the residents are still students. And so we would come back after every cycle and do some coursework in the school, with the school faculty. And what was cool about that is we as student residents would go out, see the real world, come back, and then talk about it. And so we could have this debrief processing thing instead of just graduating and saying, okay, sayonara, we're not going to have any affiliation with the school anymore. It was still cultivated. And because it was a new program, there was a more modern approach, a more entrepreneurial approach, which I would attribute to Jared Howell. He had business classes for us and talking about what does a modern O&P practice look like. And we even had discussed 3D printing and had a tiny little 3D printer that nobody knew what to do with because the digital design side of it is so crucial, as you all know. That program was very informative in terms of just giving me this more broader entrepreneurial mindset. And then the first job that I was at, working in Denver, was a traditional practice, but I was in the position of launching a new office. And so I was able to set things up a little bit more the way I wanted them to. But for the most part, it was all set up traditional fabrication methods and not using 3D design or printing. And it wasn't until the job that I'm at now where I was thrown into a position of I'm a sole practitioner, completely unsupported in a rural mountain community with a limited real estate. And so I don't have a technician. I can't invest in a full lab. I don't have the space for that. And I'm totally by myself. And that was really the spark for me to say, I can do this however I want to do it, but actually I have to set up in a way that has the smallest square footage footprint and is able to do all the things I want to do. Namely, I'm a little bit neurotic I want to have my hands on the modification process. I don't want to just pass it off to a CFAB or a technician, although obviously there's times where that's warranted. I'm like, I want to have my hands on the modification process. So if for that to be true, then I'm basically owning most of the fabrication process from start to finish, unless I'm just modifying a cast, wrapping it up, and then sending it off to somebody else to finish it, which, that does work. But it's like when there's digital tools out there and I could just scan it, take it into the digital world, and then just start making the device that I have in my mind. It came out of the whole necessity is the mother of invention. And so it's really the role that I'm in now that kind of forced a lot of that kind of transition to the digital workflow.
So just thinking back to your engineering days, and you mentioned the SLA, the 350 and the 250 and all that stuff. Did you ever see that coming into O&P, with that experience and that kind of perspective? Because I know SLA has been around for a while, but that was early on, right? It was before O&P was really looking at 3D printing.
Yeah, that was 2006 when I had that first job. That was 2006.
Okay, yeah.
And those 3D printers had been around for a while, but I just remember telling people I worked for a 3D printing company and people's minds were blown back then. And now 3D printing, there's a lot of buzz around it. But even then, it's still like this hobbyist thing or this kind of obscure thing. For me, getting into the O&P world, after this is, let's see, almost 10 years later, I'm getting into the O&P field. And yeah, that's crazy to think about. I guess so the weird thing is when I got to the O&P world, unlike a lot of my classmates who had worked as technicians or assistants or who had shadowed, they had shadowed for an entire summer, or they had worked for an O&P company for a summer, breaking out molds and stuff like that. I had shadowed that guy for 4 hours and then signed up for O&P school. So I came in with two kind of unique traits. One was I had very little exposure to the actual world of O&P because I had just learned about it. I just got into the class admission cycle in the nick of time. And so it was like, we're interviewing next week. And I just was able to get an interview at Baylor. And a lot of my classmates had previous O&P experience, and a lot of them were coming straight out of undergrad. So I had been working for 5 or 6 years at this point as an engineer and was looking for a little bit of a career change. So I came into O&P school, and fortunately it was a really good fit, but there was a lot of stuff that I didn't even know about the field. Actually, a huge portion of stuff. I think a lot of people get drawn into the field because of prosthetics and don't even know what orthotics, the field, the practice, any of the clinical presentations really are. And so I remember learning how we do this traditional fabrication method and being like, are you kidding me? This is like technology that hasn't changed since the 60s. I'm sure the thermoforming of polymers and lamination of composites, it's obviously the techniques and the materials have improved, but the basic apparatus of an alignment jig and a vacuum station and a big old oven, that just hasn't changed in a really long time. So I remember coming in as a student and learning these things in grad school and being like, really? That's what we're doing still?
Wow.
So
Yeah.
yeah, it was a little bit of a trip.
So you're like, okay, 10 years later, there might be a little bit of buzz around it, but it's around the 3D printing, but you've been doing it and seeing it. So would you say that you saw the 3D printing coming and orthotics and prosthetics was a good match for that? Or was that something that you were trying to navigate?
I hadn't, like I said, when I was at that company, I was in more of a technician role and less of an engineer role, even though it was titled engineer. And I wasn't really super close to the 3D printing technology. I wasn't in the design chair, and I was really close to the technology, but I wasn't an expert in the technology by any means. So I just figured that it was more prevalent than it actually was, looking back and seeing how rare or unique that process is. Now I see, okay, it was a limitation of materials and software. Even with freeform back then, it was just so few people knew about freeform, used it, especially had mastered it. And then to value that in the O&P field, I think it's a really big jump to see how these. I think you've probably taken a similar arc to this. A lot of people talk about 3D printing. That's the thing that's going to change everything. But then it's actually more about 3D design than it is about 3D printing. However, the 3D printing technology is obviously very crucial. And so if the design isn't there, the printing can't really happen. And once the design happens, now we can optimize the printing.
Let's actually dive down that rabbit hole a little bit. You've gone hook, line, and sinker into freeform, and you have your own kind of unique way of using freeform. But take me through the thought process of, okay, I'm actually going to concentrate on the design side of things, but I want to be in control of what you said, some of the modifications. So obviously, there's some scanning somewhere in there, modification, and I know you sometimes call it the Franken workflow, but it's a workflow that works for you. So tell me a little bit about that.
Yeah, in large part, I have you to blame, or I suppose I have you to thank for getting me into this, because early on, I saw what you were doing, and however it was that we first actually had contact, it was just, dude, tell me what you've learned. You gave me a big download of information of what you've learned being an early adopter. And as I recall, the advice was just skip over these not lesser technologies, but just skip right over filament printing, skip right over structure scanning, just go right to the big industrial stuff. By your advice, I was able to acquire a Peel 2 scanner, which has the ability to do color, and then picked up freeform and went right into it. But the hard thing for me was, okay, I have this skill set and I have this ability of doing plaster modifications, and that's all I've known. And then now I'm staring down the barrel of freeform and this fancy scanner. The scanner to me was the thing that was easiest to learn. And it's so funny to even think about scanning as a skill, but there really is a learning curve and a skill in understanding just something like 3D scanning and when to use markers and when to use foam to help bring it out, or what lighting conditions and what angle and how quick to do these things, right? And then what do you do with this scan information once the scan is complete? And how do you take color information and how do you fix scan files? And so there is a learning curve even to that side of it. But that curve is much smaller and shorter, I think.
Okay.
A little bit more straightforward. So I said, okay, I mastered the PL2 scanning fairly quickly. And okay, the digital design side of things and looking at freeform, it's this giant sledgehammer to crack a walnut of doing a couple of modifications for an AFO mold, for example. So that was a lot more intimidating, and frankly still is, because it's just this endless options for optimization and getting into stuff like you're doing with the end topology and the lattice structures and, doing all that stuff. Like, okay, yes, in theory, these things are possible, but actually doing it and executing it and then really the tricky part is doing it in a clinically relevant manner. That's really, I think, where the gap is, at least for myself, but I think also for the industry at large, is we're really wrestling with how do you take these cool things like lattice structures, like flexible materials or filament production machines, and incorporate that into something that is clinically relevant for a patient. It's safe, it's effective, it's strong, it's durable, all those things. For me, I have the Franken workflow because I'm familiar with plaster, I'm capable with plaster. Okay, now all of a sudden I have this new tool, which is the PL2 scanner, and I can just do my plaster work like normal and then scan it, and then making an AFO off of an already modified model, a positive model, is a little bit easier because I just don't have to worry about those small little strokes I took with the Sureform to get the exact shape and control patterns that I want. So that was how the Franken workflow came to be, because I have plaster and I have a scanner, and those things I know how to use. I'm still learning this freeform thing, so let's just do as much as I can in the traditional model. But I quickly realized, okay, there's a lot of this stuff that's actually easier on freeform than it is in person with plaster. And a silly example of this is doing a buildup on Malalas, for example. It's really easy on freeform to just mark out an area and do a little buildup, and it's messy and takes time, and then you have to come back and sand it and smooth it with plaster. So then all of a sudden I didn't use plaster to do buildups anymore. I would just shape it and get the controls that I want. And again, I'm more heavy in the orthotic side by a long shot. So that was the thing for me, was I kept asking, anytime I would sit in on a webinar, anybody would talk about 3D printing, 3D design, anything in O&P, it was always around prosthetics. Everywhere you look, prosthetics, and nobody's 3D printing or designing AFOs, or at least I didn't see it. So every time I would go to one of these webinars or go to a session at the academy, I'd say, who's doing 3D printed AFOs? And I didn't see a lot of people doing functional, definitive, weight-bearing AFOs. There was a lot of wrist stuff, some spine or cranial stuff, here and there, widgets and stuff, but nobody was consistently doing 3D printed AFOs. And that was the thing I was most interested in. And again, by your advice, you were able to say, look, just skip over filament printing because it's not going to be fulfilling for definitive AFOs, and just go straight to the nylon F material. And we had, with your help on the design side, we had a couple of cases at my first job where we made some AFOs and learned some things about the strut design, and those failed even though the patient loved them. But fortunately, I haven't had too many failures because I was able to jump straight into the stuff that worked, which is freeform for the design and PA12 for the print. And with the freeform and the right material, we've been able to knock out multiple devices now and haven't had a failure yet in my new role here. So that to
we'll
me,
knock on wood there too.
knock on wood, but that to me is really when the light bulb went off, as I'm sure you've explained to me before, like when you started making a socket and the patient says, oh, I like this better and it's lighter and it does more, or it's the same comfort and it's just that much easier to fabricate. All of a sudden I'm like, oh geez, this is going to be a game changer. We just have to master these tools. And so that's where I'm like really pushing hard into it, is to just be like, how does this workflow evolve? What are the tools to make this necessary and like everyday relevant, and to get into to make 3D scanning quicker and to make the modification process more accurate and to get the final print to be just the best device and safe and functional. And there's so many categories of this digital workflow to optimize. There's so many different software packages now. There's so many different scanners. There's the printing side. There's not as many definitive options, but everybody's trying to figure out, okay, how can we do filament with definitive AFOs, for example? And that's where I think a lot of exciting stuff is going to happen. And then obviously you're doing trying to push into the world of automation. And so how do we use all these tools and all these digital pieces of the workflow and to optimize? And man, I'm just super excited to see where things go, because I think we're just scratching the surface for O&P.
Yeah, no, I think that's an excellent point about just scratching the surface. I think there's a long way to go, and man, there's so many people that are talented outside of O&P that have knowledge of digital whatever. I think of people in the gaming world, and they're creating these little avatars and it's 3D, but those people have a lot to offer us, especially in the sculpting side of things and where things are going. So I'm super excited about that. Let's finish up with this. Where do you see things going for you? Like, what are some immediate goals for you as far as moving more and more into the digital space? And then we'll follow up with, if somebody's listening to this for the first time and they're like, hey, you know what, I think I may look at going digital. Where do you start? And it sounds like you've had a roadmap that's worked for you, but you've also learned a little bit. So if you were to pass it on, where would you see people start? So first, we'll start off with what's next for you, what's exciting for you about the 3D printing space and what you're wanting to do. And I love that you're focusing on the orthotic side of things. There is a much greater need for orthoses than prostheses. The volume is much greater, and I think it benefits from this technology.
Absolutely. I'm excited it's easy to make devices for cases or for patients or presentations that just aren't very complicated. But as in O&P, a lot of what we do, especially in orthotics, is very complicated. Complex presentations, cerebral palsy, spasticity, instability, deformity, all these things. It's just not straightforward. That's why it's custom. That's why it's specialized. And so to make devices that are optimized, meaning light, efficient, effective, that are safe, that are functional, right? It's like at the end of the day, that is our bread and butter. If these devices aren't functional, people don't use them. Doesn't matter how cool it looks. You can have it dyed, or you can have it with all this cool lattice work. And if it doesn't fit, if it's not functional, it doesn't matter. So that to me, I think is the real big challenge is for us is to not just make something cool, not just make something light, but to make something functional and helpful. And that goes back to the fundamental O&P skills that we learned, which is hand casting is how this process starts. And so I've gotten really neurotic with my casting techniques where I'm doing 2 or 3 stage AFO casting where it's semi weight bearing and then they stand up and then they're sitting and then they stand up, and I'm doing it in multiple stages to get the alignment that I want and to get the weight bearing alignment. That to me is the thing that I'm like, I'm still casting. I have these really thick, irregular thickness cast. I'm still spending $20, $30, $40 of casting materials every time. And then I'm still having to fill it and strip it. And that's inherently something I want to get away from, right? So I know that there is some effort to try to make 3D scanning jigs and apparatuses to maintain a good a good neutral alignment, right? But the thing for me is I often am doing weight bearing or semi weight bearing casts. So that's the thing I'm trying to tackle right now. And I'm actually working with some engineering students at the School of Mines right now to try to develop some sort of a standing weight bearing scanning jig.
Oh, very cool.
It's just going to be a rudimentary design, but a basic idea of how can we support the limb that is dysfunctional, hold it in a weight-bearing alignment that is functional, and then scan it. And that's the thing that I'm like, if we can figure that out, we can start the digital workflow much earlier in the overall workflow process. So that's the thing that I'm trying to go after right now is just pushing myself to scan more and cast less, because I think that'll just force me to be more digital. And the question is, can we still maintain accuracy and functionality? And that's the big challenge for me. And then the next piece is then always trying to improve AFO designs. There's just so much that has already been done. And so it's okay, how much more can we improve these things and optimize these things and take what we know about biomechanics and then just bake it into a 3D printed orthosis. I think there's going to be some cool things once we master the software and the design side of things. We're going to be able to make some pretty cool things in terms of the unlimited or seemingly unlimited realm of 3D printing. I think there's going to be some pretty cool stuff that comes out of that we just haven't even realized yet. And I'm really excited to see what happens there.
Yeah. No, that's perfect. Thanks so much for coming on, man. If somebody can't take a nugget away from this, I don't know. There's something wrong, because you have covered so much and there's a lot of great information in here. And so thank you so much for coming on. And
if I can just cut you off real quick, you had mentioned previously like what's the big takeaway?
Oh, yeah.
I know a lot of people, or a piece of advice I heard from you a lot, which was just start scanning. Scan your molds, scan your modified plaster molds, and just make a digital library of molds. That's one of the easiest ways to just get your hands, quote unquote, dirty in the digital workflow. And if you have an iPad and a structure sensor and something like DigiScan, just make a model library. And that is the easiest way to just start. I think that's great advice. And in addition to that, I also have realized, I think along with everybody else, that like scanning is worthless if we don't have the ability to design and modify. And so I think a lot of these newer cloud software that to do modification is coming into play. And I'm super excited to see that, because I think it's just going to give people on easier cases, on more straightforward projects, the ability to just do it and to just get into it. And I think that sort of stuff, they're tailored to O&P. That's my biggest beef with Freeform, is it's not tailored to O&P. And so you have to figure out how to make it do what you want it to do versus the UI just being based around O&P. And so I'm super stoked for all these O&P based systems coming out. And I think it's going to get people into the process just that much easier without having to bang their head against the wall of learning the freeform learning curve. So I think just a lot of those companies will let you just demo it. And if you have a scanned AFO model and you put it into one of these softwares and then just design an AFO with the help of one of their sales reps, bam, you just did digital workflow. And I think the 3D printing side will come. I think more and more companies are going to get printers. But in terms of just getting into it, it's like you have to have a scan and you have to have software to modify it. So just start simple, scan a modified plaster model and put it into one of those simple cloud-based systems, and you're off to the digital workflow races. And I think that's just how I would, if I were to like push reset on my practice right now, I think that's the place that I would start, because you can start so much more simply. But I just jumped into the deep end and went straight for the most complex cases and the hardest stuff. And then all of a sudden it's, oh dear, there's a lot to learn here.
Yeah. No, I think that's great. Scan, learn to modify. And yeah, there's a ton of resources. YouTube has become an amazing resource for
Absolutely
some, I wouldn't say scanning, but some of the modification stuff. Again, thanks for being here. Thanks for sharing your expertise. I love that quote that you said, if I had to reset, this is what I would do. So there is a nice nugget in there that hopefully somebody will take to heart. So thanks again for joining us, Drew.
Absolutely. Thanks for having me, and glad to talk the O&P digital workflow, because it is certainly an evolving thing, and I'm sold out. I'm trying to see where it can go, and I'm super excited to have other people just make some amazing breakthroughs and push this thing as far as we can push it, because at the end of the day, it is about the patient outcomes. And I think, as you've pointed out many times before, it's like these technologies are not in a vacuum. They are put onto a real person, and they have real influences and real implications for people's functional abilities. And it is so cool to just see somebody, oh, this is 3D printed and it works better than my other device, or it works just as good, but it's lighter. That's the fuel for the fire.
That's awesome. Thanks again. This is the Orthotic and Prosthetic Podcast with Joris Peels and Brent Wright. We hope you will join us on another episode sometime soon. Thanks.